how do we connect to internet, and all those things we will be discussing in today's class. I'll share my PPT. Okay, so in today's class, we are going to discuss about the network edge part. All right. And what is that we are going to discuss in the network edge part is if we talk about internet. Okay, internet is really, it consists of massive number of devices, informations, applications, API, connections, and all those things are present in the internet. And if we think about the overall architecture of internet, we have three layers. Okay, we can thought about internet in this way. That is, you have the access layer, then you have the distribution layer, then you have the core layer. So all our end devices sit in the access layer, that the outer ring, which is in yellow color, there is where your end devices, servers, and all those stuffs are there. Then distribution layer, you have your networking devices like your switch, for example, your router, and everything comes under the distribution layer. 3 switch, all those things come under the distribution layer. And the core part of the internet, where there are redundant high-speed networks or switches, routers, and routing protocols. So all those things in the core part. So anywhere else you want to establish a communication, you have to start from the access layer, go to the distribution layer, then through the core part, you will be reaching the other part of the distribution layer and to the access layer. So this is how all of the internet applications travel in the internet. Okay, now what is there in the access layer? You have end systems, servers, all those devices that we discussed in yesterday's class. You have the PC, laptop, tablet, smartphones, your cars, toasters, webcam, gaming consoles, everything come under everything, all of us reside in the access layer. Now, any application, if you see in the network, it falls on 2 categories. Okay, one is the client server application, the other one is the peer-to-peer application. So what is a client server application? So there is somebody who needs service. They are called as clients, and there are somebody who provides service, and they are called as the servers. Okay. Now, again, if you have any questions, I encourage you to post it in the chat box. I'll try to answer. Otherwise, I'll try to get the answer for you. Right. Now, coming to the class, we have the end devices, and I told you the applications fall under 2 categories. So client and server applications will have some devices which will be always asking for service. For example, your mobile phones, maybe they run say n number of applications in the client panel, and they will be asking for service. There are some sophisticated server. Example, let us take a Facebook application. So there is a mobile, and you connect to the Facebook through the API available in the mobile. So your mobile is a client, and there is something called a Facebook server where all your data are stored. Your selfies that you take, your photos that you post, your messages that you post, your news feed, everything is stored in the server over there. The second category is called as the peer-to-peer application. Peer-to-peer application is nobody is master, nobody is slave. So all of us try to help each other and try to establish a small connectivity. That is how the applications of internet works. So now, where are the servers actually? So this is a very good example of a client and a server application. See, traditionally, maybe some 5 to 10 years before, all the servers are hosted in the customer premises itself. So now they will have, for example, let's take our university itself, our Karni University. So what do they do in the Karni University? They just have a local web server, they have a local DNS server, they have the mail server. So all those servers are maintained, or your lab applications running server. So all those servers, they are maintained in the customer premises. Okay. So number of applications that access those servers are very less. So maintaining such servers in the customer premises is really a little bit okay job. But now you think of Facebook. There are millions of users accessing the Facebook. Think of Instagram. Yesterday we did a survey, or we did a questionnaire session where 500 million users per day are accessing the Instagram server. So in such cases, they cannot have it in the customer premises. So what do? Is they have it in a place called data center. Okay, so that is where is the data center come into picture. Well, what is actually a data center? So you could see the picture of Google's data center here. See how many racks of servers are there. Okay, so you see here in this picture, there are n number of racks where lights are glowing. What does this? What does it mean? It means that the server are very busy accessing, giving service to the various applications. So this is an external premises of a data center. I would also like to show a small video of how a data center is. It will be a little bit noisy, please bear it. But I want everybody to listen. Okay, this was the video about Google's data center. How actually is the Google data center? So I'll show it from the end till the security systems, how the server room, how the networking room, everything is well explained there in the Google data center.
Get ready to go inside Google's cloud. The tech giant has 12 data centers around the world. They are the engines that make Google run, and they contain a lot of sensitive information about you.
This presentation, this video was taken maybe 2 years back. So they say that 12 data center, but now Google has many more than what they have previous years. I'm sorry for this.
Get ready to go inside Google's cloud. The tech giant has 12 data centers around the world. They are the engines that make Google run, and they contain a lot of sensitive information about you.
Now, for the first time, the company has invited cameras inside its top secret facility in North Carolina. Michelle Miller went along for this story that you'll only see here on CBS This Morning.
With all the patrols, fences, barbed wire, and steel barriers designed to slice through cars, it would be easy to mistake this place for Fort Knox.
Hello.
But it's really a Google data center.
Yes, ma'am. Do you have your ID on you?
For many years, the company refused to admit these even existed. Even today, no visitor may enter without first signing a non-disclosure agreement.
Just saying that you're not going to take any unauthorized pictures, or you're not going to talk about anything that you see.
Inside, security is just as tight.
Thank you.
Retina scans determine who has access, something even many Google executives don't have. Every single person entering and leaving is tracked. If more than one person enters through the doors at once, alarms sound. Have you ever had a breach at this facility?
No.
Never.
No. Let's go in.
Our tour guide is Google's Senior Vice President, Urs Hotzle, known for his trademark red socks and one of the company's first employees.
My first job title was search engine mechanic. And I picked that because everything was broken. Google was down, searches took 5 seconds.
Now Hotzle is in charge of building and running all of Google's data centers. In the industry, you're known as the infrastructure czar.
Mm-hmm.
Flattered by that?
Yes.
Yes. Our first stop, the networking room. It's like air traffic control. Every time a user asks Google for something, that request is first routed here and then directed to another computer on the server floor. How many servers are on this floor?
So today we have 55,200.
The sheer size and scale of the place is breathtaking. Employees must wear earplugs to protect their hearing from the constant whir of tens of thousands of machines.
So each of these servers basically is like a PC except somewhat more powerful.
And when one of those servers goes down, we saw firsthand what it takes to repair or replace them. Okay. Right here. How about that? Recently, the industry came under fire for being energy hogs, consuming huge amounts of electricity to keep servers running in air-conditioned rooms. On our tour, Google was very eager to show us how they were reducing their carbon footprint here at the data centers. That's because the company is very protective of its green image, according to Wired Magazine's Stephen Levy. He has covered Google for years and also got a tour of the Lenore Data Center.
The opening up of data centers really comes from their feeling that they can't keep this themselves.
Google reduced a lot of its energy consumption by simply raising the temperature on the server floor from a chilly 68 degrees to a balmy 80.
We're estimating that we saved over $1 billion in the history of Google through these efficiency measures.
At Lenore, Google says only 10% of the electricity is not used to power its servers. Another Google innovation, replacing wasteful air conditioners with a water-based cooling system. But for all of the company's efforts to become energy efficient, a lot of their power still comes from non-renewable sources.
The power here is coal. The power here comes from whatever the local utility provides.
Which isn't clean energy.
Which in North Carolina is about 2/3 coal. Yes. We are currently at about 35% of renewable energy, and we're aiming to get eventually to 100%.
Google says this is the only time they'll allow TV cameras inside their server floor. But in an effort to be more open, they say they will put up video and pictures of all their data centers on their website.
It's amazing how all of this works and that it works at all. And the fact that they always do is really amazing.
For CBS This Morning, Michelle Miller, Lenore, North Carolina.
It's interesting to see inside, but I wonder if it addresses some of the privacy concerns that people have about Google.
Well, it's interesting you said it because Michelle actually came out with a printout of your whole search history.
We'll be looking at that later.
Okay, so now we all look at the video how Google data center is, and maybe your Gmail messages, your whatever we store in the Google, and all those stuffs, your classrooms information, maybe everything is stored in any one of the server that they showed. Okay, maybe in our nearest data center it is stored. Okay, now why I showed this video is it is to show you what about the server nowadays, how the servers look like nowadays. Okay, so these are all the end devices. They all lie in the access layer. I showed you 3 circles in the start of the class. So all these devices lie in the outer circle of the internet. Now, coming from the outer circle, how do we connect to internet? Okay, usually how do we connect to internet? The first class I asked you this question, most of you replied you use modem, you use cellular technology, you used Wi-Fi, and all these stuffs were replied by you. Okay, so we all connect to the internet through these mechanisms. All right, so here also we are going to discuss about quite few technologies which help us to connect to the internet, especially the home devices to the internet. So the first one was DSL. Okay, what is DSL? Can somebody type in the chat box? Can I have the response in the chat box? What is DSL? Yes. Children, are you all listening? I hope you're all listening to my class, sitting in the class. What is DSL? Any response? Yeah. Digital subscriber line. Good, good. Digital subscriber line. Yes. So this is what is the picture of digital subscriber line. So here are we. It connects with the telephone network, and we have a DSL modem, and also the DSL modem. Nowadays, DSL modem comes with the built-up splitter too, and it just split the signal into voice for your home, and also it also split your data. And now here is what's the upstream and downstream data frequency is. And it just terminate in a place called DSL access multiplexer. Okay, so DSL access multiplexer is responsible for connecting many users information, or it's responsible for splitting many users information to their respective home. Okay, it takes it to the respective home. That is you might have seen a small box at the end of your street, or by the end of your maybe 4 streets together, you will see a small box at the road. So that is what you are seeing here. Okay, and which again moves to the nearby bigger internet. Okay, so this is how the DSL network works. The upstream and downstream data rate, I don't want to mention it here in the class. You can just refer your book or the class presentation that I have uploaded. Okay, I have uploaded the textbook PPT separately. So you can refer the upstream and downstream. Upstream means the data that moves from your home network to the internet. Most of you would have known this definition, but again, I'm telling you. Okay, upstream is nothing but the data that moves from the home to the internet, and downstream is the data that moves from, or the flow that moves from the internet to your home. Okay, so the rate your textbook and PPT. Technology, there are symmetric DSL, there are asymmetric DSL, there are digital DSL, analog DSL. So they have many varieties in the digital subscriber line technology, very traditional one. The second one is cable. Okay, so you might have heard of cable used only for television network in our country, but cable network, even in some part of our country, the cable network is implemented, right? So anybody know in which part of our country the cable network is done? Can you just give your answers? Right? If you know, you can give the answers. All right. So cable network is Mumbai. Okay. So cable network is one network which is really, it is used in European countries first. Okay. They were the first to heavily use cable network. As we all use DSL, those people uses cable. Now, how does it happen? There is again a small box. You call it as cable head end. Okay, a small box, as you see a small exchange at the end of your street or end of 4th Street together, you will see a small box, and there is something called CMTS. So CMTS is cable modem terminating system. Okay, so that is called as CMTS. And from the CMTS, either coaxial cable here or fiber optics cable. Okay, so any one cable takes it to the fiber node. From the fiber node, using coaxial cable, it is distributed to the home. Okay, so unlike the TV network, okay, TV network, most of us have seen that TV network has only the downstream data. You can only download, see the data that the provider provides to us. But here in this cable network, you can even upstream it. Okay, it provides data, not only voice and audio and video, it also provides data. So this is how the cable network works. So there are a few components I want to stress it: CMTS, then the fiber node, and from the fiber node, the coaxial cable runs. The next well and known technology nowadays, every service provider is, first BSNL started, and now every service provider, almost Airtel, Jio, or Vodafone, or Idea, they are trying this because it's very, very high speed. FTTH. What is FTTH? Somebody give the answer in the chat box. FTTH. So they have experimented it. They found that it was good. That is why, because of all these technologies only, we were able to get Google or Facebook, your applications in a flick of a second. Okay. Now you say, as you see in the video, the vice president was telling that earlier when he joined Google, it took 5 seconds for a request to get a reply. But now it is not even a flick of your eye. Okay. Yes. Akhil, good. I'm getting many answers. Narulmoli and Joseph. Yes, who was the first to answer? Arpit was the first person to answer. It is fiber to the home. Okay. So now very important is the ONT, optical network terminator. So optical network terminator is a small box that is given to us. Okay. So if suppose you want to fiber to the home, you have to go and you have to get that small box, as you get the modem for DSL and cable modem for cable network. So you have to get the optical network terminator. So what happens is, in the optical network terminator, they'll give for voice, you can connect to your computer. There are n number of ports available, maybe 4 ports, I guess. Okay, 4 ports are available where you can just do it. Okay, I'll show you. So optical network terminator consists of 4 Ethernet ports and 2 telephone ports. Now there are 2 types of connections in the FTTH. One is active optical network. The other one is a passive optical network. So what about the active optical network? Active optical network is what I have shown here. There is some electrical device here. Okay, so here is your exchange. So all these blue color cables you see is the optical cable. Okay, there is one big electrical device here. Maybe you say it is a repeater. It can be your repeater. Okay, so the repeater repeats the signal that is received from the service provider and it sent it to the respective ONT, okay, optical network terminator. And here is where you are, okay, this A, B, C, D here is where we are. So there are, here you see that they have both, okay, they have data as well as voice. Here they have only the data. So this is how the active optical network works. And as we are implementing a repeater here, the distance that is provided, the number of service that is provided by an active optical network is relatively high. Okay, you see it's at least routed to 500 ONT, and the distance is also 70 kilometers here and 20 kilometers here. The next one is the passive optical network. So passive optical network has some traditional switches here. They don't have repeaters, but they have traditional switches here. And again, here is a optical line terminator. Okay, optical line terminator. So the optical line terminator just gives the signal here, and then it is converted into a optical network terminator, and it goes on. So what is the purpose of optical line terminator is, in the optical line terminator, from A, for example, let us take, there is a user A. He sent a signal to the splitter, and from the splitter, it goes to the optical line terminator. And beyond the optical line terminator, it is converted into electrical signal here. You understand? Okay. So here there is an optical line terminator. So the optical line terminator is, main role of optical line terminator is to convert electrical signal to optical signal. Similarly, from optical signal to electrical signal. So these are all the splitters, and the total distance that is carried out here is 20 kilometers. Okay, they are all very networking devices are actually implemented here. Instead, in active, the amplifying devices are implemented. So this is how the active optical network and passive optical network works. And in most of the cases, we don't rely on. Okay, so congratulations to every students who did well. I'm so happy. Nitin, Pratyusha, and who came first? The first answer, I don't remember. I'm sorry for that. I'm so happy about that. Okay, now we all move to the class now. I'll present the screen. Okay. Now, so far we discussed some technologies that helps to connect home to the internet. Okay, home, maybe we all at home using our laptops, mobiles. So everything, how do we connect to internet is what we discussed so far. Now we are going to discuss how to connect an enterprise. For example, there is a company building. Let's take, for example, our Karunya network. This is a KU network picture which was taken very before. I've taken this picture. So let us take, I hope you all didn't forget the building, CSE building, CSE. You can give response in the chat box. I'm just checking the chat box also. So you remember the college. I hope you don't forget that. It all be a sweet memory for you all, right? Even though you are so sophisticated at home, you won't remember this place where you have lots of memories to carry out. Okay, now, so how actually the network is? We have our lab computers. Let's take Cisco lab. Okay, so Cisco lab is there in the 3rd floor of CSE building. So there are 30 to 40 computers, and those computers, how do we connect it to the internet is, we use twisted pair cable. Okay, so all the twisted pair cable together we connect to a switch. Okay, then from the switch, how do we connect it? From the Cisco lab switch, we take again a twisted pair cable. Okay, maybe UTP6 cable, and we connect it to the 3rd floor switch. From all the 3rd floor switches, again they are connected to a switch that is at the ground floor of the CSE building. So this is how that building is connected. And then what happened from there? Nowadays we use fiber optic cable. Okay, earlier we were using coaxial cable, and now we use fiber optic cable. From the ground floor switch, a fiber optic cable run to to a switch that is there in the CTC. Okay, there are intermediate switches also, but for simplification, I'm saying this. So what is the main technology used there? We use Ethernet, we use switches. Okay, so this is how we connect the, see this picture here. Here is a user, he sits before a computer. There are a number of switches. Okay, the star switches is layer 3 switch. What is the difference between layer 2 switch and 3 switches? they actually have a little bit of routers characteristics in it. Okay, so that is what is the difference between those two switches. Okay, now from that switch, they all take the packet to a central switch there in the CTC. So from the central switch, you connect it to the outside through firewall. Okay, this you see that central switch, this cable move here to the firewall, from the firewall to the external router, and from the external router it goes to the internet. Okay, this is how an enterprise network is located. So here you see a DMZ zone, demilitarized zone. Usually we host servers over there. It is a very secure place. We host servers, your clouds, and all those are hosted in the DMZ zone. Okay, so this is how an company network will be. Okay, now you may ask me a question, ma'am, even at my home I use a switch. Okay, it's true. Even we just develop a company like structure, company devices, twisted pair cable, all those are used at our home also. Or do they just provide a small internet service providers, they provide a small jack at your home where you connect a Wi-Fi router to the jack, and from the Wi-Fi router all of you in the home access the internet. So that is also possible. That is what I'm going to show you in the next diagram. It's a Wi-Fi network. Okay, so in most of the company, if you visit, maybe you would have visited a company for your internship, you would have visited for a few companies for your industrial visit. If you would have observed there, even in our college, you would have observed access points. Okay, so then and there you will have access points, and all your laptops, your mobile phones, you can connect it through the laptops. Okay, that is what is called as the Wi-Fi network. And then in little bit of wide. Okay, so all these are local area network. A little bit of wide I want to connect. So in that cases, we go for a technology called cellular technology, right? Cellular technology. So all G's come here. So we effectively use cellular technology. Even most of you are listening to this class using cellular technology. Okay, you just put a hotspot from your phone. You establish a small wireless network between your laptop and your phone, and then your phone is connected to a cellular technology, and you all do it. Okay, so here is a little bit of difference: 1G, 2G, 3G, 4G, and 5G in terms of devices and in terms of the year. Okay, when it was fully established. Okay, so the 1G network, it take care of only the voice. The 2G network, it take care of voice and messages. The 3G takes care of voice, messages, and little bit of multimedia. And then the 4G and fiber optics, implemented using fiber optics high-speed technology, which take care of all sorts of applications. Then coming up is the 5G, where many more characteristics are added to it. We are going to see how 5G operates. Okay, so in maybe in another 2 slides. Now, quickly, I want you to give some 5 minutes of time. Take your mobile phone, take your internet, maybe Google and tell me what is the full form of all these. Quick, your answer.